Do you have any questions? Any questions about solving by completing a square? No? Okay. If you don't have any questions, I think we would like to move forward. We are going for this semester. We're going to skip 53A. Those are I will leave it as optional exercise. You can do them. Those are exercises you can do, but we're not going to spend time in class. Okay. So 53A. 53 are for you to practice. You certainly have the you have the means to do it. You have the means to do, and so we're not gonna cover this in class. We actually want to move to the next section, which is a 54A. 54A. This is a logarithm. Okay, 54A. 54. Okay, alpha. 54A. Okay. Regarding 54A, we would like to talk about. We like to work on this section. There are lots of exercise in this section, but I like to start this section with something that you are more familiar with, which is exponents. Okay, earlier on we reviewed, we studied exponents. Do you guys still remember which section we did that? Yeah. The exponents. Which section did we study the exponents? It was right before this. Let me show you. Okay, which section? I'm looking for it. It's in alpha 33, alpha 33, 34A, and so on and so forth. Okay, so recall the operations on power. Okay, so that is alpha 34A. So what did we study there? Okay, what did we study there? Okay, so something new. We're gonna we in 54A that we're heading to. We're heading to logarithm. We're heading to logarithm. Okay, logarithm is a big topic. It's a big topic. Okay, I'm not sure we can finish all of it in the notes, but we're gonna do as much as possible. Okay, for your future classes, I hope this will be a good introduction. All right. Now, with that, we are going to review. First, a review about these operations. Okay, for example, we have studied that if b to the power of m multiply b to the power of n, what would that be equal to? It equals to b raised to the power of m plus n, right? We have derived the whole of it, right? We derived the whole of it. And what else have we studied? We have also studied, I'm going to put this on a table. I think at the time we set up a table, right? So when we have a table, it's a little bit easier for us to transport. Okay, it's a little bit easier to transport these tables. So let's start with this table, right? B to the power of m multiply b to the power n right? So I want you guys to look at 34A, 34A, 34A. Are you guys looking at 34A? $34A. Okay, I'm gonna bring this up. I'm gonna share that screen with you. 34A, revisit, we're gonna revisit this section. Okay. I'm gonna bring this over here and a new share. Does everybody see this? Remember we were here? Okay. At the time we use a different base. We used A. You can use B as a base. It doesn't matter. You can use anything as a base, right? The only thing that we're not going to we're going to make sure is that the denominator cannot be 0. So whenever we have a denominator, the denominator cannot be 0. So these are the things we have learned. I want you guys to write them down. I want you guys to write down this one. Okay, so please write down. Okay, this is in 34A in your notes. And I want you guys to write down. Okay, copy this, that, and give the formula. Okay, and give the formula. Okay, write down this one, that one. May not be so much this one. We don't use this very much. And this one, and these. And I want you guys to write down the formula. Okay, because the formula wasn't here unless you have it in your note. Okay, so write down 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Could you do that please for me? Write these down on your notes. Did you write it down? I'll take care of this. Some students submit their work and I cannot read their work. This is from my other class. Okay, I'll take care of that after class. But anyway, so you write that down. Okay, so we're going to go back to the other screen. We're going to go back to the other screen. Okay, so b to the power of, let's see, I'm going to move this over here to the other piece. I have two screens, so I can move these, my reference. Anyway, okay. So b to the power. So I just changed a to b. Okay, but whether a is the base or b is the base, it really doesn't matter, right? So that's b raised to the power of m minus n, right? Okay. And the other one is b raised to the power of 0 equals to 1. B raised to the power of negative n is 1 over b to the power of n. Okay. One more. Actually, this is a very important one. There. It's b raised to the power of m, and then raised to the power of n equals to b raised to the power of m times n. Okay? All right. Now, we're going to study in more details about these properties. Okay, so get your paper, pencil ready. Get your paper, pencil ready. Okay, get your paper, pencil ready. Oh, this student texted me to my, that's why I don't see it in Pronto. He sent it to my text message. All right, so I'll just quickly reply him. All right. So now when we look at these properties, right? When we look at these properties, okay? When we look at these properties, I'm going to make a connection between what we learned here to logarithm. Okay? So I'm going to completely change the way I would approach these topics. Okay, I'm changing the way we approach these topics. All right. Are you ready? Okay. So take this one, for example. Okay, we're going to start from the easy to more complicated. Okay, from the easiest to more complicated. So with this table, okay, does anybody have any questions about this table? Does anybody have any questions about this table? No? Okay. And I'm gonna rearrange the table. Okay. So the first one, this one, okay, of course there's a requirement that b is not 0, right? I consider this one is the easiest. So I'm gonna put it over here. Okay. And these, I'm going to put it over here. Dividing, I'm going to put it over here. And this guy, I'm going to put it over here. And last but not least, okay. And I'm going to add another row. I'm going to put this guy maybe here. Okay, maybe here. But I am going to insert another row to put the basic concept, over here. So b raised to the power of, right, b raised to the power of n. Okay, suppose it equals to something. Okay, suppose it equals to something. Okay, and then we're going to start. Okay, and to start this, I'm going to insert another row, because we're going to look at the different cases of b. Suppose b is equal to 2. What happens if b equals to 2? Well, all of these, b equals to 2, when the base is equals to 2, b is not 0, that's guaranteed, right? 2 is not 0. So 2 to the power of 0 is equals to 1, right? So 2 to the power of n is going to be equals to, I will call it omega. Okay, this guy is called omega. You can also call it baloney, okay? And in this case, what will happen is that 2 to the power of negative n is equals to 1 over 2 to the power of n. And this property will rewrite, right? When b equals to 2, this is going to be 2 to the power of m, 2 to the power n to 2 to the power m plus n, yeah? And over here, that's going to be, oh, b is 2, b is 2, b is 2. Last but not least, there. Okay, when b is 2. Okay, now we're going to introduce logarithm. Okay, we're going to introduce logarithm. Logarithm is just a notation, but it involves some definition. What it says is that if 2 to the power 0, right, you can see that 2 is the base, 0 is the power, and 1 is the result, right? 2 to the power 0 is 1. So what we do here is that we're going to introduce logarithm. We're going to write it as a logarithm base 2, the base go here, right? Base 2 of 2 to the power 0 is 0. Okay, so that's a logarithm. So these two are considered the same thing. It's just a different notation, One is emphasizing the result of the power, and the other one is emphasizing the power. Do you follow me? Okay, so log is basically an operation to give you the power. And this is called exponential. Exponential is just to give you whatever the power will lead us to. Okay, so the consequence of power. So for the same sentence, the other way of saying it is log base 2 of 2 to the power 0 or 1 is equals to 0. And the other words that you take the 0, you power the 2. You take the 0, you power the 2, you get 1. You guys follow me? Do you follow me? So it's a different way of saying the same thing. Okay, it's a different way of saying the same thing. Okay, sorry. All right, so I'm going to insert another row. So put these words in here. Column. Okay, so what this is saying in other words, or i.e., that is. Okay, so 2 to the power 0 equals to 1 in logarithm form is saying logarithm base of 2 of 1 is equals to 0. Are you guys following me? Excuse me. Now let's look at 2 to the power n equals to omega. And what is the other words of saying it in logarithm? It is saying, well, logarithm base of 2, the same base, right? The same base of omega, baloney is equals to what? Is equals to n. And what does that mean? Okay, so let's play with some numbers. If 2 to the power of 3, what is 2 to the power of 3? 2 to the power of 3 is 8. And then we say log base 2 of 8 is 3. Do you follow me? So on this row, I'm going to insert some more rows. And we're going to practice this. Okay. 2 to the power of 1 is equals to 2. And i.e., in another word, in the other words, it is saying log base 2 of 2 is equals to 1. So one is expressing the consequence of power, and the other one is expressing the power alone. Okay, for example, in California, in LA here, we often experience earthquake, right? Just the other day, I was in the yard. My husband was he came out of the yard. He came out of the house and tell me there was an earthquake. Actually, I didn't feel anything. Did you guys experience? Did you guys experience the earthquake a few days ago? Yeah. Good. Well, the earthquake is measured in Richter scale, right? In Richter scale, you hear the radio saying, "Oh, this earthquake is 3.2 Richter scale, or 4 Richter scale, 5 Richter scale." What does that mean? It's a level of power. It's expressed in common log, in common logarithm. Okay, common log, logarithm base 10. Okay, we're going to talk about that. Okay, so first we're going to talk about 2. Okay, earthquake measure is a common log base 10, which we remove 10 by default. This means log base 10. Okay, so we're studying something related to how the measurement for earthquake. Okay, and the operation related to it, Okay. Now, if 2 to the power, I want you guys to practice this. Okay, 2 to the power 4 is equals to 16. Can you write the logarithm form of it? Can you write the logarithm form of it? Yeah. Yes. What is it? It's going to be logarithm, log base 2 of 16 is equals to what? 4. Right? So now I want you to look at these two numbers. Okay? I'm going to switch these 2 rows, actually. Okay? I'm going to put these rows over here. Okay, you can see the logarithm value in power 3 and 4. The difference is only, what's the difference? The difference is 1. But in terms of power, 2 to the power 3 and 2 to the power 4, what is the difference? 2 to the power 4 is 2 times 2 to the power 3. It's twice as much. Okay, so the logarithm value different by 1, but the power, in terms of power, is twice. It's twice. Okay. So far, so good. Now, so let's look at base 10. Okay, let's look at base 10. So we're going to get to base 10. Okay, we're gonna look at base 10. For base 10, okay, we're not using the other stuff yet. We're not using the other stuff yet, okay? So I'm going to take this piece. I'm going to make another table, and you guys need to practice with me, okay? And this time, I want to change base 2 to 10. Okay? 2 to 10. So this is 10. And this is the log 1 equals to 2. I'm sorry, log 1 equals 0, right? Common log. This is called common log. Common log is called a common log because it's used often in a lot of practice. For example, it's used in earthquake, the earthquake expression, right? So when we say 10 to the power 0 equals to 1, what does that mean? That means the log 1, log base 10 is log base 10 of 1 is equal to 0. Okay, so we have this power. This says 0 power 10 is 1. 0 power 10 is 1. 1 is here. Okay? Now I want you guys to write something else. Okay? 10 to the power of 1 is equals to 10. So in logarithm form, what would you do? You would write log of 10 equals to 1. Right? How about 10 times 10? 10 times 10. 10 times 10, we know it's 10 squared, right? 10 squared. 10 squared is what? It's 100, right? 10 squared is 100. And that is the log of 100 equals to 2. You follow me? This 2 power the base 10 here, base 10, okay, so by default is the base 10. So 2 power 10 is 100. 100. Do you follow me? Now keep going. 10 to the power 3. 10 to the power 3. 10 to the power 3. We're going to come back to this later, okay? 10 to the power 3 is 1,000. And in the logarithm form, in another word, is a logarithm 1,000 equals to 3. Okay, so once again, let's look at this phenomenon. 10 to the power 3 is 10 times 10 squared. Right? 10 times 10 squared is 10 to the power 3, which is 1,000. 10 squared is 100, right? Just let's look at just these two numbers, right? 1,000 is 10 times 100. But logarithm 100 is 2. Logarithm 1,000 is 3, right? The power difference is only 1. The difference in power is only 1. Okay? But the difference in power is 10 times. Now, let's look at the earthquake measurement, right? If you're told we have a Richter scale of what? Of a 4 versus a Richter scale of 5. Earthquake is about this. Okay, Richter scale of 5, a Richter scale of 4 is 10,000, which is equals to 4. Richter scale of I'm going to remove this, okay, because I'm going to make way. I'm going to show you in terms of measurement, okay, with the power, okay. So logarithm 150 equals to 5. So a Richter scale of 4 and Richter scale of 5, the power, okay, what's the difference in power? This says is 10 to the power 4 equals to 10,000. And this is 10 to the power 5 is 100,000. So the Richter scale of 4, comparing with the Richter scale of 5, is 10 times in power. Do you follow me? So if even though you hear the earthquake report in the radio, right, or whatever, TV or whatever source, right, you know, social media, the actual power you feel, the difference between power 4 and power 5, it's 10 times. As if you talk about destruction, it's 10 times as more as destructive. And Richter scale is measured using common log. Does that make sense, you guys? Any questions? It's the same power. It's the same power. But we just, instead of talking about 10,000, we're talking about 4. Richter scale 4. Richter scale 5. But you know the power is, it's 10 to the power 5. And the power is 10 to the power 4. Okay? And how about Richter scale of 6? Richter scale of 6 is 10 times stronger than the Richter scale of 5. All right. So now let's look at this. Okay, Richter scale of 6. I don't know how strong an earthquake you have experienced. Okay, so let's work on this. Okay, let's work on this. Okay, we have 5, 6, 7, right? So we're gonna do 6 and 7. Okay, a Richter scale of 6. Okay, that's 10 to the power 6. Richter scale of 6 is very strong, very strong. 10 times stronger than a Richter scale of 5. Now, log base 10 to the power 7, which equals to 7. The Richter scale of 7 is 10 times stronger than a Richter scale of 6. Now, my question is, Richter scale of 7 is how many times stronger than Richter scale of 5? Did you get my question? Did you get my question? Did you get my question? Okay, I'm going to write down my question. Okay, I'm going to write down my question. Okay, Richter scale of 7 is how many times stronger than Richter scale? Did I spell that correctly? The Richter scale of 5. You guys follow me? We know that Richter scale of 7 is 10 times Richter scale of 6, and Richter scale of 6 is 10 times of Richter scale of 5. Okay, so now our question is, the Richter scale of 7 is how many times stronger than Richter scale of 5? It's 100 times, isn't it? 100 times, isn't it? How do I know it's 100 times? Yeah, it's because 10 to the power 7 is what? Is 10 to the power 2 multiply 10 to the power 5. Right? So you have 10 to the power 5, right? So the magnitude, the Richter scale tells us one number, but the magnitude is 10 times stronger as you increment by one number. So Richter scale of 7 is 100 times stronger, more destructive than Richter scale of 5. That's why it's so devastating. That's why when you hear the number, you see the devastation. Okay. In 1994, I was here for the Northridge earthquake. Okay, at the time we live in East LA, and it was 6 point something, right? It was 6 point something. Okay, when I was a young person, when I was like 10 years old, when I was in China, there was an earthquake reported 7.8 Richter scale in a city near Beijing. The entire city was flattened. Okay, hundreds of thousands of people died. Okay, more recently, we hear Richter scale report about earthquake happening in the ocean, right? In the sea of Japan, near Japan. And all these earthquakes, if you look it up, you look at the numbers and you think about the power, right? In relative terms, you know how strong they are. I personally have experienced earthquake of the Northridge earthquake is the strongest one I personally have experienced. The earthquake in China, and because I was at the time I live in very far away from the city, but I still felt, I felt it. Okay, so that was it was much stronger, because much stronger than the Northridge earthquake. It's at least 10 times stronger. Okay, of course they're not whole numbers, but it was nearly 8. 7.8 is nearly 8. It's a very, very strong earthquake. Okay. Any questions so far? You can see the logarithm is used to express the power, to express the power according to a certain base, right? For example, the 7 is referring to 10 to the power 7. Okay, so this 7, in this case, is telling us that 7 power 10 is 10 to the power 7. So over here, that means 10 to the power 6 is equals to what? 10 times, right? 10 to the power 5. 10 to the power 5. Anyway, so you can write it in many different forms, and you can write it as 10, it's a million, right? It's a million. 10 to the power 6, a million. Okay. All right. Are you guys ready for some more exercise? I'm going to have you guys fill out the form, fill out another table with base 2, because base 2 is relatively easy. Okay, so I'm going to have you guys fill out the base 2. Okay, so let's continue. I'm going to put some more rows. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to put in 4 more rows. Okay, so 1, 2, 3, 4. There you go. Okay, you guys are going to continue to practice the logarithm. Okay. Now, this time I'm going to put numbers on both sides. Okay, say for example, I would put 2 to the power 5 equals to, I'm going to leave this blank. On the other side, I'm going to write it as logarithm form. Log base 2 of the question mark equals to 5. Okay. And over here, I'm going to write log base 2 of 64 equals to, I'm going to give you a random symbol, triangle, okay? And over here, I'm going to have 2 to the power of, I'm going to be creative. Okay, make it heart equals to 4 and log base 2 of 4 equals to the heart. Okay, so you need to decide the number. You need to decide the number for the unknown question mark. Okay, you need to fill out this part and one more. 2 to the power of and that equals to 128. And then you're gonna write the entirety in logarithm. You're gonna write the entirety in logarithm. Are you ready? Okay, fill in the blanks. 1, 2, 3, 4. 4 blanks. 4 blanks for you guys to fill. Everybody must participate, okay? Otherwise, you're gonna be lost. If you don't follow at this beginning introduction, you are going to be lost. So don't get this, don't get distracted. Focus on this simple practice. Okay, so I'm gonna make it. You just have to work this part. Is that clear? Just this piece. Well, you don't even have to look at that whole thing. How about that? Just this piece. Fill in the blank. Fill in the blank. All right. So what number should be here? So 2 to the power of 5 is what? 2 times 2 times 2 times 2 times 2, 5 times, right? What does that equal to? Marcelo, what does that equal to? What is 2 to the power of 5? Put your answer on chat. Brianna? Francisco? Alan? What is 2 to the power of 5?
32.
Perfect, 32. So log base 2 of 32 is equals to 5 because 5 power 2 is 32. Okay, 5 power 2 is 32. Okay, so in this logarithm expression, we have a base, we have the consequence of power, and we have the power. Okay, the power on the right, and it's on one side. So we express the power alone. So now next, log base 2 of 64 is something. So that something, what is that something should be? So you're gonna fill out the entire blank here in power. Right? So that triangle power 2, right? The triangle power 2 equals to 64. What should be that triangle? 6. Okay, does it work? And this should be what? 6. Very good. Very good. Next, this one should be, everybody should know how to should get it, right? 2 to the power of the heart equals to 4. So log base 2 of 4 equals to the heart. What should the heart be? Brianna? Marcelo? Francisco? Are you there? What the heart should be equal to? What should the heart be equal to? 2. Excellent. Good job. 2 squared is 4, right? Last but not least. Okay. 2 raised to the power of something equals 128. On the other side, we want you to express it in logarithm. Okay, we want you to express it in logarithm. So what would that be? This blank. Someone, Francisco says 64. 64. 64 for what? Where do you want me to, what do you think I should be putting the 64? 2 to the power of what equals 128? And you need to write down the entire thing over here. And where do you want to put the 64? This expression, well, this number is something, right? And this expression, you're going to write a logarithm of something. Is it going to be equal to that heart, right? So what? So there are two things you need to decide. What should be the heart, and then you're going to give another form. So Francisco, I don't know what you meant by putting 64. 64 is for what?
Would 64 be the power, 2 to the power 64 to get 128?
Have you checked it? Have you checked it? Does 2 is
You
2
divide 2 by 128.
2 divided into 128 is equal to 64. That is true. But 2 to the power of 64 means what? 128 divided by 2 equals to 64. What does that imply? That just imply 128 is equals to 2 times 64. It doesn't tell you 2 to the power 64 equals 128. You know what I mean? Do you know what I mean? 2 to the power 64 equals what? Two to the power 64 is equals to 2 times 2, 64 times. 64 times. Okay. Do you think your 64 is in the right place? 64 times. Is that what you meant? Is it true? Is it true? Do you still agree with what you did? You said? It's not true, right? Is it? So how should you figure this out? Two multiply 64 and 2 to the power 64, they're not the same thing. Do you see that? 2 multiply 64 and 2 to the power 64, they're not the same thing. So what should this number be? How do you find out that number? You started by dividing by 2 is a good thing. It's a good strategy. But when you compose it, that's the problem. That's the problem. Okay, so I'm gonna take you guys to the next line. I'm gonna take you guys to the next line. So how do I figure out this question mark? How do I figure out that question mark? Okay. According to your proposal. According to your proposal. Okay, so I'm gonna put it here so that we can have a coherent, so that it's a little bit easier for you to take notes, I hope. Okay, how do I figure out this question mark? Right? So first of all, I have a 128, right? And you just noticed that you told us that 128 divided by 2 is 64. And this will lead us to 128 is 2 times 64, right? 128 is 2 times 64. So 128 is equals to 2 times 64. And you take this, and if you continue this process, right? You take 64 and you divide by 2, and you're gonna get what? What are you gonna get? You're gonna get 32, right? And what does this tell you? This tells you 64 is 2 times what? 32, right? So 128 is equals to 2 times 64, and 2 times 64 is 2 times 32. And you take 32, continue the division. That's equals 16, yes? And what does this tell you? Are you guys writing it down? So 32 is equal to 2 times 16, right? So you continue this process. So you have, now you have 2 squared already, right? You have 2 squared already. And then 32 is 2 times 16. So 2 times 16. You guys see how this process goes? Yeah? And you keep going. By this time, you already recognize 16 is 2 to the power 4, right? Yes? Let me line them up so you can see that easily. 128 is 2 times 64. 64 is 2 times 32. 32 is 2 times 16. So you have a 2 squared there. So in the end, you get 2 to the power 3, right? Which is these two numbers. Multiply 16 is 2 to the power 4. Yeah? Do you agree? So in the end, what do we get? We get 2 to the power of what? 2 to the power what? 2 to the power 7 multiply 2 to the power 4. What do we get? Hmm? Hello? Are you guys there? So that's 2 to the power 7, right? Okay. Or if you don't want to do the power, you can just do 2. You just keep doing it, right? But we can do this way. You guys are not answering my questions. Are you guys there? Okay. 64 is 2 times 32, and 32 is 2 times 16. So you keep doing that. You can do this way. Okay. You keep these 2's. Okay. And 16 is 2 times 8. Right? And 8, you just keep going. Just keep going. Right? And 8 is 2 times 4. And eventually 4 is what? 4 is 2 times 2. Right? So in the end, what do we get? 128 is 2 to the power 7. Not 2 to the power 64. Okay, you better check. Okay? When you come up with a number, you have to check it. Okay, so now we know that 128 is 2 to the power 7. 2 to the power 7, where do we take that back to? Right here, 2 to the power 7 is 128. And you got to check it. You got to check it. How do you check it? You go backward, right? 2 to the power 7 is 2 times 2, 7 times. And then you go, you do 2 times 2, you get 8, you get 4. And then you time another 2 times 4, you get 8. 2 times 8, you get 16, right? And 2 times 16, you get 32. And 2 times 32, you get 64. And 2 times 64, 100, you get 128. Right? It's a reverse process. So how do you write the logarithm form? How do you write the logarithm form here? This is our transition to logarithm. How do you write it? Hmm? How do you write it? Could you write it down and upload it on Pronto? Upload it on Pronto. Because I want you to see your handwriting and write it down properly. Okay, for example, over here, right? I want to see your handwriting. Okay, so this would be written as log base 2 of 16 equals to 4. Something like that. You don't need to type. I want to see your handwriting. Okay, most people don't do typing when they turn in their work. I type it because I want to make sure, you know, everything is concise, precise. I type it because I can. Okay, most people when they do math, they're not gonna be able to type, right? It's not just available, and you need to write it down on your paper. And this, so you need to write down something here. Okay, here to fill in the blank, something like this, something similar to this. So what would that be? So how would you fill this entire blank? Fill that blank entirely. So far, so good? Are you there? Everybody? Could you submit your work? Or you can try to do that on the chat. It wouldn't be easy though, because they don't have the typesetting. Are you guys there? Are you hiding from me? Are you hiding from me? Brianna, would you please submit? Alan, Francisco, Marcelo, please. Hello guys, please, did you hear me? So how should the submission look like? How should the question mark look like? Okay, I'm gonna give you the answer right now and we'll take a break, okay? It should look like this. Log base 2, 128 equals to 7. All right. So let's take a break. Okay, come back in 10 minutes. Come back in 10 minutes. Okay. Grab something to drink. I mean, if you're hungry, but just grab a little snack and come back. We're gonna practice some more of these. Okay, I'm gonna practice some more of these. Okay, it's a new chapter. It's a new chapter. It's not easy. Okay, I'm trying this way of introducing logarithm. Logarithm is the hard topics. Is a hard topics for a lot of our students. Okay, so I hope I will give you a good introduction, a good introduction to these topics. So let's take a break for 10 minutes and come back at 11:50. Okay, so back at 11:50. I will see you soon. let's summarize. Okay, let's summarize. We have done some exercise here, and I also want you to notice some interesting phenomena. Okay, we have a 2 squared equals to 4 in logarithm form is something like this. So I'm going to move this guy to that place because I want you to observe some patterns. I want you to observe some patterns. Okay, I want you to observe some patterns. 2, 4, 6, 16, 30, 62, 64, and so on and so forth, right? Okay, so this is what we did. 2 to the power 0 is equivalent, okay, is the same as log base 2 of 1 is 0. Okay, 1 is also equals to 2 to the power 0. And when we take a logarithm of 2 to the power 0, which is also 1, right? 2 to the power 0 is 1, 1 is 2 to the power 0, and the answer, that power is 0. So these two numbers are the same when these two powers are expressed are the same. You see that? This is the log base 2, and this is the power 2. When these two powers are the same, and the power, whatever you have, will go to the answer. And log base 2 to the power of 1, 2 to the power 1 is 2. 2 to the power 1 is 2. So this is 2 to the power 1. And so the answer is 1. 2 to the power 2 is 4. 4 is 2 to the power 2. So this 4 can be written as 2 to the power 2. And the answer is 2. You guys see that? Now, 8 is 2 to the power 3. 2 to the power 3 is 8. So this can be written as 2 to the power 3. And the answer is 3. Okay. 2 to the power 4 is 16. 16 is 2 to the power 4. So 16 can be rewritten as 2 to the power 4. And the answer is 4. Okay. Do you guys see that? And 32 is 2 to the power 5. 2 to the power 5 is 32. And 64 is 2 to the power of 6. And 128, as we did, we have figured out, is the same as 2 to the power 7. Okay, so now we're gonna have more questions just about base 2. Just about base 2. Okay, are you ready? Okay, I'm gonna make another table. I'm gonna make another table, but this time, of course, we're not gonna work on the same table. Everything will be changed. Okay, everything will be changed. Of course, this stays the same. We're gonna put a negative sign in front of each one. Larger fonts. Okay, so all of these will have to be redone. This one still is the same. Okay, 2 to the power 0. But only one stayed the same. Okay, so here, all of these will be changed. Okay, I want you guys to practice with me. Actually, I'm going to put this table above it. Okay. 2 to the power 0 equals to 1, right? We have done that. 2 to the power half, 2 to the power negative 1, what would that be? What would that be? Over here, right? So now I'm gonna insert another column here, okay? I'm gonna insert another column here for your practice. Okay, we know that b raised, still make it bigger font so you can see better, okay? B raised to the power of -1 is equals to what? 1 over b to the power of 1, right? Okay, we have a general formula. B to the power of -n is equals to 1 over b to the power of n. Okay, of course, this one is b to the power 0. We know that, right? When b is not equals to, and in our case here, let's just use 2 to the power 0, okay? So now, 2 to the power -1. So now this is changed to 2. This is changed to 2. What would that be? What's 2 to the power -1? That's going to be 1/2, right? So this will be log base 2 1/2. That should equals to -1. You follow me? So I want you to practice, okay? B raised to the power -2 equals to 1 over b squared. 1 over b squared. So when b is 2, and this is going to be what? This is going to be a 1 over 2 squared equals to 1 over 4. So this is a log base 2 of a quarter is equals to -2. Okay, and you can also write it as log base 2 of, okay, so I'm giving you all these examples here. And I want you guys to fill in the blank for the rest of them. You ready? Log base 2, 2 to the power -2. Okay, please, you must practice. Okay, if you don't practice, with me, and then you're gonna be lost. Okay, you don't want that to happen to you. Okay, do you have any questions so far? Okay, right now we're working with a negative exponent. And your task is to work these out. Okay, to work these out, this is a -3, and this is 1 over b to the power 3. And this is a -4. And this is a 1 over b to the power 4. And this is a -5. And this is 1 over b to the power 5. -6. 1 over b to the power 6. And then you're going to apply in the case that b is 2. You're going to do all of these 1, 2, 3, 4, 5, and you fill in the blank on the other side. Okay, I'm just going to grab some tea and I will be right back. I'm back. How's it going? Yeah. All right, guys. How's it going? Okay, let's come back to do this together. Are you ready to compare some notes with me? Compare your work with the work we're gonna do together? Okay, so let's see. 2 to the power negative 3 is what? Is 1 over 2 to the power of 3, which is what? 2 to the power 3 is 1/8, right? It's 8, right? 2 to the power 3 is 8. Therefore, 1 over 2 to the power 3 is 1 over 8. So we got 2 to the power negative 3 is 1 over 8. So when we put a logarithm, that's going to be 1 over 8 equals to negative 3, which is also the same as log base 2 of 2 to the power of -3. So -3 goes down there. Okay, 2 to the power -4 is 1 over 2 to the power 4 equals to 1 over 16. Okay, so over here, you will write 2 to the power of -4 equals to -4. Of course, you can also write it as log base 2 of 1 over 16 is -4. Okay, so far so good? Are you guys there? Brianna? Alan? Francisco? Marcelo? Are you getting it? Okay, so 2 to the power -5 is 1 over 2 to the power 5. And that's 1 over 32. So on this side, you can write 1 over 32 log base of 2 raised to the power of -5 equals to -5. Is it getting easier? Is it getting easier? All right. Now, 1 over 2 to the power 6. Okay. I think someone put on the chat message. Oh, okay. It's getting easier, right? Okay, but if you have any questions, don't hesitate to ask me, okay? These are pretty tricky, but if you go through your hands, you're gonna get better at this. Okay, and that's going to be equals to 1 over 64, right? 1 over 64. So on logarithm base 2, you're gonna have 1 over 64 equals to the same as, because 1 over 64 is the same as 2 to the power 6. So 2 to the power, I'm sorry, 2 to the power -6. So the answer is -6. Okay. Now, this is 1 over 2 to the power 7, which is going to be 1 over 128. And this is a log base 2 of 1 over 28 equals to log base 2 of 2 to the power of -7, and that's equals to -7. Okay. All right. So that's about negative power, right? So we did a positive power, we did some negative power, but they're all whole numbers. How about fractions? How about fractions? Right? How about fractions? So for fraction, I have another group of exercise for you. Okay. So these are powers are fractions. Power are negative numbers, right? And we did a power that are a 0 or positive integers. Then you say, how about fractions? What do you mean by the power to be fractions? So let me give you some examples. Okay, let me give you some examples. So I'm gonna make another table. Okay, still for base 2. It's still for base 2. Okay. Suppose we have square root of 2. Okay. Square root 2 can be expressed as 2 to the power of half. Okay, 2 to the power half. Okay, 2 to the power half. And then what is the logarithm expression? 1, 2, 3, 1, 2, 3. Okay, so what is the logarithm expression? The logarithm expression will be log base 2 of square root of 2 is equals to 1/2. Okay, so you can put it in any order you want, really. Okay, you can put it any order you want. Okay, so 2 base 2 of square root of 2, right? The square root of 2 is the square root of 2 is really 2 to the power of half. So it just take the half and bring it down. Okay. Now, how about some other fractions? 2 to the power of, say, 3/2. What is 2 to the power of 3/2? 2 to the power of 3/2 is 2 to the power of 2/2 plus half. Just practice with these numbers. 2/2, of course, is the 1, right? So that's 2 to the power of 1. 2 to the power of 1, sorry. 2 to the power of 1. Multiply 2 to the power half. Okay, 2 to the power half. I'm sorry, I made a mistake, okay? I made a terrible mistake. It's a power half. Okay? And 2 to the power half is root 2, and 2 to the power 1 is 2. So this is just 2 times square root of 2. When we write it in logarithm form, what would that be? It would just be log base 2, okay, of 2 to the power 2 times root 2 equals to 3/2. Okay, you can also write it as log base 2 of 2 to the power 3/2, sorry. 3/2. You guys follow me? Okay, so how about some negative powers? How about some negative powers? For example, I'm gonna insert another row. Right? How about 2 to the power negative 2 to the negative power? Just put a negative sign there. And that would be what? That would be 1 over square root of 2. Right? And in logarithm form, and that's going to be log base 2, 1 over square root of 2 equals to negative half. It gets a little bit more challenging, isn't it? It gets a little bit more challenging. But it is also equals to log base 2 of 2 to the power of negative half. So all these notations, I hope you guys are following me. Do you guys follow me? So we had done base 2, down base 2. Let's look at base 10. Let's look at base 10, right? Let's look at base 10. We did a base 2, and we did base 2 with positive exponents, negative exponents, right? And the fraction, some examples, okay? And we did a base 10, okay? So let's summarize what we did on base 10. Okay, let's summarize what we did for base 10. I'm gonna bring it to the top. Right, I'm gonna bring it to the top, base 10. So what do we have here? When base is 10, we had all these operations. I'm just gonna trim some of these operations. Right, 10 to the power 7, that's a 10 million. 1, 2, 3, okay. 1 million. Oh, I put it one more zero than I should. Sorry. Okay, sorry about that. Okay, so let's come back. Let's look at base 10. Let's look at base 10. Okay. Log base 10, we just read it as log, common log. You can say common log. Okay, just read it as a common log of 1 equals to 0. And common log 1 is also equals to common log 10 to the power of 0, which equals to 0. Common log 10, right? 10 is 10 to the power of 1. Right? So common log 10 equals to 1. Common log 100. 100 is 10 squared. So common log 100 is 2. Common log 1000, which is 10 to the power of 3, is 3. And we have 4 0 here, so that's 10 to the power of 4, 10,000. Right? 100,000. 10 to the power of 5. 10 to the power of 6, 10 to the power of 7. You guys see that? Do we see the pattern? Do we see the pattern? You guys see the pattern? So what is the pattern? Common log implied the base is 10 by default. And the power we have here is 10 as well. So common log base is 10 and we have power 10. So in that case, the answer of common log 10 of 2 whatever power, it just equals to that power. Okay, so when the log base and the power base match, okay, so whatever the power, it is going to be the power. That's going to be the answer. Okay, do you guys see that pattern? Common log 10 to the power 4 is 4. Common log 10 to the power 5 is 5. Common log 10 to the power 6 is 6 because they have the same base, okay? The log base and the power base are the same. So far, so good. Yeah? So now, I want you guys to look at some negative power. Negative power. Okay? Negative power. So this is going to be turning to -1, -2, -3, -4, -5, -6, -7. And of course, all of these numbers will have to be rewritten. Rewrite these numbers. You can write it as a decimal fraction, any which way you want. And all of these will have to be reworked. Reworked. Okay, 10 to the power 0. But this one we did already, right? So this is just really 10 to the power of 0. That is still 0. No change. We make the fonts larger. Okay. 10 to the power of -1. According to b raised to the power of -n equals to 1 over b to the power of n. B to the power of n. Okay, so when b is 10, so this would just be what? 1 over 10 to the power of 1. 1 over 10 to the power 1 is 1 over 10. 1 over 10 is also equals to 0.1. Right? So this is the fraction form and this is the decimal form. 1 dime, right? 10 cents. If you're talking about money, but the fraction 1/10 is 0.1. So now in the logarithm form, how do we write it? We write it in 3 different forms, right? If we put a 10 to the power -1 there, it is just equals to -1. And we can also write it as log 1 over 10. Okay, we can also write it as log 0.1. They're all the same. Okay, this means same as. 10 to the power 2. 10 to the power 2 is 1 over 10 squared. 1 over 10 squared is 1 over 100. 1 over 100. 1 over 100 is 0.01. Right? Keep going. Log base 10, which is a common log, right? I can write it this way. And that's going to equals to -2, right? I can also write it that this way, which is 1 over 100. That's also equals to -2. And I can also write it as a log 0.01. 0.01, that's also equals to -2. Of course, I didn't write this way, which is 10 to the power -2. 10 to the power 2, 1 over 10 to the power 2, right? Can you guys fill out these blanks? Your turn. It's your turn. Okay, if you want to show me your work, please send me to Pronto or inbox. Keep trying. You're getting there. How's it going? So 10 to the power negative 3, right? It's 1 over 10 to the power 3, right? According to the power, negative power interpretation. And that is also equals to 1 over 1000, and that's equals to 0.001, right? And the log form will be, if you write it as 10 to the power negative 3, and the answer is going to be negative 3. Or if you write it as log of 1 over 1000, it is also equals to negative 3, right? And if you want to write it as log 1 over 10 to the power 3, it is also equals to negative 3, right? So these are different way of writing. I'm going to leave the rest of them for you. So could you make sure you write down the questions? So please write down all of these and you're going to practice with the rest of them. Got it? We're going to get to logarithm, 54, alpha 54a. We're going to get to alpha 54a. Okay, so now let's go. Alpha 54a. In alpha 54a, you're going to see a variety of different bases now. You're going to see a variety of different bases. You not only see base 2, base 10, you also see other bases. You're going to see other bases. So I'm going to take you guys through some exercises so you know what I meant. Okay. So over here, what I'm going to do is that I'm pretty much regenerating the same table. Okay. So this title of this is Logarithm and Exponential Form. Okay, so we're going to generate this. We're going to have 2 columns and more rows. Okay, so one is the exponential form. One is the exponential form, and the other one is logarithm form. Logarithm form. Okay, so one is exponential form, one is logarithm form. For example, the first one we have log base 3 of 81, that equals to 4. And the blank we need to fill up is 4 power 3 equals to 81. So 3 raised to the 4th power equals to 81. Okay, the next row, the second question is 10 to the power 4 is equals to 10,000. And in the logarithm form, you're going to write a common log 10,000 equals to 4. Get it? Get it? Okay. So next, I want you guys to practice in class. I want you to practice in class for all of them. We have 14 questions. I think we can do it in no time. Okay, we can do it in no time. Okay, so this is number 1. Number 2. Number 3. I'm going to use the same number. 5, 6. Okay, so let's do 3, 4, 5, 6. 3, 4, 5, 6. Number 3, we're given a logarithm form. Log base 3, okay, base 3 of 1 equals to 0. You're going to write the exponential form. Number 4, you are given a exponential form, and we want to write it as logarithm form. Number 5, you have a log base 5, 1/5. That equals to -1, and you're going to write it in exponential form. Number 6, you have a 6 squared equals to 36. And now you're going to write in a logarithm form. So how do we write these forms? Okay, so next, I'm going to give you a general form of the exponential and logarithm, which we have done, right? Which we have done. The exponential form would be a base of a b raised to the power of triangle is equals to baloney. The logarithm form, however, is going to be the logarithm base b of omega, which where baloney is equals to triangle. And these two are the same, okay, equivalent. So in between, I'm going to insert a column, and I put an equal sign. Equal sign means, equivalent, okay, arrow, this one. Okay. Do you guys know what to do? So for example, on this one, right? We have the base is 3, omega is 1, and triangle is 0. So this means that 0 power 3 is equals to 1. So then you just write it down here on this side. 0 power 3 is equals to 1. That's it. On this one, you're going to write log, right? We have practiced quite a few. Hopefully those practice will help. Base 5 of 1/25. Okay, the base is 5 in logarithm. They have the same base. Okay, now 1/25. So that's the omega. 1/25 is omega. B is 5. And triangle is -2. So on the other side, omega goes to the logarithm, base is the same as 5, and the other one would be -2. So the power goes to -2. Next, I want you guys to try this one. So that will be 5 raised to the power of the -1 is 1/5, right? 1/5. Now, number 6, okay? If 6 squared is 36, then log base 6 of 36 is equals to 2. Do you think you got a hang of it? Did you get the hang of it? Okay, so let's continue. Let's continue practice this table. Okay. We're gonna do a few more. Let's insert, so maybe 4 more rows. I'm going to choose number 9 for you. Number 11 for you. Number 12. And number 14. Okay, they're a little bit more challenging. Okay, 9, we have a log base of 8 of 2 equals to 1/3. You say, how come? To write the exponential form. Write the exponential form. Okay, so I put them in place. Number 9, number 11, we have a logarithm, common log 0.01 equals to -2. We did this one earlier. Number 12, we have a 2 raised to the power of -3. This is not unfamiliar. And number 14. Number 14, so we have a 4 raised to the power of -3/2 equals to 0.125. So we have 2 logarithm form to exponential form and 2 exponential form to logarithm form. Try that. Need answer there? No. We need answer there. We need answer there. We need answer there. And we need answer there. Okay. So what would that be? That would be 8 to the power of a 3rd equals to 2, right? Which is a cubic root. which is really cubic root, right? It's 8 to the cubic root. Okay, so cubic root of 8 equals 2. So that's what this statement is saying. 1/3 power 8 is taking cubic root of 8. That's equals to 2. And this one is saying what? 10 to the power of -2 is equals to what? 0.01, which is 1/100, 1/100, 0.01, right? Now, last two. We write it as a logarithm. Okay, so you can write it as logarithm of base 2 of 1/8 is equals to -3. The last one is a little tricky, right? But if you just follow the format, right? Hold on. You just follow the form, okay? I'm gonna make this form closer to us, okay? Insert a row here. I'm gonna bring the form with us. Just put it here, right? B is 4. The triangle is -3/2, and the omega is 0.125. So over here, you would just simply write it as logarithm base 4, 0.125 is equals to -3/2. That's it. Okay. So far, what we have seen are the transformation between exponential form and logarithm form. Okay, exponential logarithm. So when you see exponential, you should think of it as a logarithm form. When you see the logarithm form, you should thinking of the exponential form. And the logarithm exponential, there's just two sides of the same coin. There's just different way of saying it with different emphasis. For example, when we see the power, we really just care about the power. What's the value of the power, right? We have a -2 as the power, and this power 10 equals 0.01. But if we want to emphasize the power, and then we use a logarithm. We use logarithm. So we say, okay, common log of 0.01 is -2. Or -2 power 10 is 0.01. Make sense? All right, I hope I haven't repeated myself too much. Okay, I hope I haven't. If you need more exercise, alpha 54b will be a good place to go to as well. Okay, so now let's look at 55a. Let's look at 55a. Okay, alpha 55a. This time we are going to see power, we're going to see logarithm alone. Okay, we're going to see logarithm alone. So the connection is, you have to make the connections in your head. Okay, so start with the first one. Are you guys with me? The first one, we're asked to give the value of power log base 3 of 9. So what number, so this is asking us, what number power 3 is going to give us 9? What number power 3 give us 9? So what will be the answer? What will be the answer? Marcelo, can you tell me the answer? Could you please tell me the answer? What number power 3 is equals to 9? So this is asking you, what is the answer to log base 3 of 9? What is the meaning of log base 3 of 9? It's asking for the power, and that power the base and give you 9. So what will be the answer? What number power 3 equals to 9? Alan? Francisco? What is it? 2. Excellent. Perfect. That's it. Right? So that's how you work it. Number 2, we have log base 2 of 8. The answer is a power. And that power 2, produce 8. So what number power 2 produces 8? 3 to the power 2. Excellent. Okay, that equals to 3. Perfect, Marcelo. Okay, so let's look at number 3. Log base 2 of a quarter. What number power 2 will give us a quarter? What number power 2 will give us a quarter? Okay, you can look at your notes. What number power 2 give us a quarter? Francisco? Marcelo? Ellen? Sometimes you need to work a little, right? Sometimes we need to work a little. So to work a little, right? So log base 2 of 4, 1/4, and 1/4, that's going to be 1 over 2 squared, right? And you can use a little bit of negative power, which is 2 to the power negative 2. Guess what you get? You don't have to go this route, okay? You don't have to go this route, but there are different ways to figure this out, but ultimately, you know, the answer you're looking for is a power. That power the base, give you the number in the position of omega. And the answer is what? It's negative 2. Okay, ready? Let's keep going. Number 4. Number 4. Okay, we have log base 7. Log base 7. 1 over 7. What does that equal to? What number power 7 give us the 1 over 7? What number power 7 give us 1 over 7? The answer? The answer? What is the answer? Alan. What will be the answer? We can work a little, right? We can work a little. We can write it as log base 7. 1/7 is 7 raised to the power of what? -1. So the answer is what? -1, right? Is that right? Okay. So now let's try number 5. Whoops. Number 5. Number 5. Oh, for some reason, I lost that page. Okay. Number 5. Could you please work on number 5? I got it. I'm back. Yeah, we should redo the typesetting. Okay, so number 5. It's a log base A and A to the power 5. So what number power A equals to A to the power 5? So what answer would that be? 5, right? Now, number 6. Log base A of a cubic root of A. What would that be? Well, we just need to rewrite a little. If you need to, sometime you may not need to, because over time you're gonna be so much better at this. Okay, so what number power A equals to A to the power of 1/3? Of course, that's 1/3, right? Now number 7, you should be able to answer number 7. Okay, common log 1,000. Number 8, common log 0.01. Do we have answers for those? What's the common log 1,000? What number power 10 equals to 1,000? That's the answer we're looking for, right? So you're looking for that power. That power 10 equals to 1,000. So what that power should be? I'm looking at the chat. Ellen, Marcelo, Francesco. What is it? What is it? Hmm? So what is log 1,000? And you just know the answer is a number, that number power 10 equals to 1,000. And that number should be what? What should that number be? Come on. You know it. You don't want to tell me? Ellen, what number power 10 is 1,000? You guys are hiding from me, right? Okay, I'm gonna give you the answer. It's a 3, right? Because it's log 10 to the power 3, isn't it? Right? So 3 power 10 is 10 to the power 3, okay? And over here, this is sometimes you feel like a tongue twister, right? But oftentimes the answer is staring at you. Okay, so that's going to be 10 squared for 100. And that's equals to, if you have to work it, sometimes you don't need to go through this lenses to work it, because the answer is right there, and the answer is -2 right there. Okay. I think that's all for today, and I have assigned you homework on Alpha 54A and Alpha 55, number 1 through number 12. And we will continue 55A next time. Okay, we're gonna do some more detailed work. And hopefully I can give you guys a good introduction on logarithm. And your homework would be, your homework has a sign, and you should expect 2 quizzes about logarithm this week. Okay. And I will see you guys on Wednesday. You have a great time. Have a great day. Okay. Thank you.